So here's our scenario. A recent poll of high school students indicated that 15% of students have recently experienced extreme levels of stress. Students in a health class decide to ask a random sample of 160 students if they have experienced extreme stress. We're going to find the probability of different types of samples being collected down below on parts A, B, and C. Let's kind of run through a few different things that were given to us. That 15%, is that the population proportion or the sample proportion? Is that everybody or is that some of them? This 15%.
Everyone.
That's a recent poll of all high school students, kind of like a nationwide poll that was conducted. That would be the entire population. That's our P. That's our population proportion. We're going to assume that 15% of all students in the population have experienced some sort of extreme levels of stress. How many people were polled? What's our sample size? 160. In part A, I want to find the probability that more than 10% of the students in their 160 student sample have experienced extreme stress. What's the probability that more than the 10% of students in the sample have experienced extreme stress? This 10% is our p hat. That's our sample proportion. More than 10% of students in this sample have experienced extreme stress. We're going to assume that our distribution is normal, but let's first check to make sure that that's a reasonable assumption using these three conditions. We're going to assume that our sampling distribution of sample proportions and sample means becomes normal. Well, let's make sure that's reasonable first. Were these 160 students selected for the poll randomly?
Yes.
Yeah.
First condition. So 160 students, less than 10% of all students in high school, less than 10% of all the population. Yeah. Now let's check to make sure we have success failure condition also satisfied. I need to be sure that I have an expected number of 10 students that succeed by having extreme stress and 10% of students that fail not having extreme stress. Take n times p, n times q. That would tell us the expected counts in each of the two categories, having stress and not. So 160 for n times by population proportion of 15%. 160 times q. If 15% have stress, what proportion do now? 85. Let's see here. 15% times 160. That more than 10? It's got to be, right? Because it's 24. Well, if that's greater than 10, I'm pretty sure that 85% of 160 would also be greater than 10. You can check that as well. Obviously 136. So those are both greater than 10. So we're going to assume, reasonably assume, that a normal distribution applies, and we can use z-scores to find each of these probabilities. Our z-score formula, the difference in our two proportions, p hat minus p, divided by the square root of p times q over n. The difference in our two proportions divided by the standard deviation, square root of p times q over n. Let's see here, 0.1 minus 0.15 divided by the square root. Let's see here. What's going to be in my standard deviation? P times q would be what two numbers? Is P 0.1 or 0.15? 0.15. P and Q are the population proportions, so P is 15%. Q would be everything else, the other 85% that do not have stress. Divided by 200. All right, so 0.1 minus 0.15 divided by the square root of 0.1 times 0.15. I get a z-score of about negative 1.9.
Shouldn't it be 160 students?
Yeah, I was
Oh, where'd
gonna
I get
say,
200?
where's the 200?
I don't know, where am I getting 200? Thank you.
You are paying attention.
There we go. Now my z-score is better, negative 1.77.
This is.
Why is it a negative z-score?
Teacher for a month.
Just a good review on normal distribution. Why is my z-score negative? Less than what I would have expected. I want to find the probability that more than 10% of students have extreme stress. I would have expected to get 15% of them to have stress in their lives. I had less than I would have done, a negative z-score. So let's go ahead and look up the probability of a z-score that is what? Greater than negative 1.77 or less than negative 1.77? Why greater than?
More than 10.
More than 10%. So if you go to your z-score formula sheet, let's familiarize ourselves with how to use a z-table. One side has all the positive z-scores, one side has all the negative z-scores. The ones in 10th place would be in the rows, the hundredths place would be in the columns. So a z-score of negative 2.45, negative 2.45 would be 0.0071. That tells you what part of the distribution, for example, would lie to the left. The z-score is defined to tell you what proportion is in the left tail, to the left of your z-score. So let's look up a z-score from our example. Negative 1.77. Negative 1.77, if I scroll down, is going to be negative 1.77, which is 0.0384, that value here. So is that my answer or not? Which tail do I want to find the probability of? The right tail, because it's more than 10%. I have the left tail, I have the other part. So what do I do to find the answer in the right tail with my value from the left tail? Subtract it from 1. 1 minus 0.0384. Is that it, right? Yeah. It is 0.9616. There's a 96% chance that when they pulled 160 students, more than 10% of them would have had extreme levels of high stress. Let's try and let part B here. Less than 16% of students in the sample have extreme stress. Less than 16% of students in the sample have extreme stress. Well, let's go ahead and find the same z-score. What is p hat this time? What's our sample proportion? 16%. Here is p hat. Our z-score is the difference of the two proportions. P hat minus P. How much more or less from our population proportion of 10% are we in our sample? So 0.16 minus 0.1 divided by that same standard deviation calculation, the square root of P times Q over N. So 15% is our population proportion. 15% of students had stress. 85% the other part did not. Divided by not 200, 160. That right this time.
Wouldn't it be minus 15% instead of 10%?
Yeah, shoot. I'll get it right one day. I'll get it right one of these days. So let's see if I go back to my calculator. 16% gives me a z-score of 0.35. 0.35. We're going to go to the z-table and look that up. Which tail do I want to have for my answer? Less than would mean what? Which tail, left or right? Left. I want to have the left tail. What's the probability that less than 16% of students polled had extreme stress? So the probability of a z-score less than or equal to 0.35 would be what? 0.35. If I flip over to the positive z-scores, 0.35 is 63.68%. (63, 64% chance that when they polled their students, 60% or less would have high levels of stress. Does this kind of sound familiar from z-scores from first semester?
Yes, sir.
Awesome. Now let's look at part C. One minor difference here. I want to find the probability that between 12 and 17% of students have extreme stress. How is this question going to be done?
Do it.
Okay, so I have it between 2%. What do we have to do with those 2%? Find the z-scores for both of them, look up those respective probabilities, and then take the difference. What's between 12 and 17% will be the difference in those two probabilities from your z-table. Let's try the 17% first. I'll let this be p hat for my first z-score. Let's find the z-score for 17% of students having extreme stress. P hat minus p, 0.17 minus 0.15 this time. Over the standard deviation, the difference from what you expect in terms of the standard deviation. Is the square root of 15% times 85% divided by 160. Let's see, and that z-score was 0.71. So the next z-score. What's p hat this time for my next z-score? 12%. Find your second z-score for the other endpoint between 12 and 17%, the left end. 12% minus 15% of the difference in the two proportions. Difference from what we'd expect, divided by the square root of 15% 85% divided by 160. Negative 1.06. So let's go to our z table and look up those two proportions. The probability of a z-score between negative 1.06 and 0.71. So we gotta find.
Theo Corcoran, report to the secondary
I'm
office.
in the middle of
Theo
class.
Corcoran, please report
just
to
1
the
minute, please.
secondary office.
Negative 1.06. 0, 1, 2, 3, 4, 5 is 0.1469. 0.71 on the other side was 0.7611. So we'll take the difference of 0.7611 minus what was the other one? 1.06. 0, 1, 2, 3, 4, 1446. Negative 1.06 is that number. 0.71 was that number. So we need the difference in the two. 0.7611 minus 0.1446. 61.65%. Tell you what, let's get some practice here. Questions so far, anything? Does anyone need an extra z-score? I actually have a few more of these. Anyone need a z-table? I put a PDF on Schoology if you need it later too. All right, get your laptops opened up and let me show you what we're working on next.